4NA Revision Chapter 2 Arc Length Sector Area Radian. Now let's take a look at the following question. Now in this question here, we are all going to work in radians because the question actually mentioned finding the angle AOB in radians. So the first step that you need to check is to make sure your calculator is in the radian mode. Do you know how to change your calculator to the radian mode? And do you know how to change it back to the normal degree mode? Okay, and first rule of the thumb that we must always remember, 180 degrees is equals to pi radian. So therefore, 360 degrees will be equivalent to 2 pi. So these two numbers will be very useful. And of course, we know 90 degrees will be equals to pi over 2. Alright, let's take a look at the question over here. The diagram shows a sector of a circle with center O. So this is the center of my circle. Radius is 12. Something else to take note, if this is the radius, is 12. Where else is the radius? Is this the only portion that's 12? No, right? You also have this one to be your radius. So therefore, you must quickly think of that. This whole thing BO is also 12 cm. Right, for radius, these are some of the common tricks that you probably need to use. Next one, a question, a point X is on the line OB such that AX is perpendicular to OB, so we have a 90 degrees over here. The length of the arc itself, so the length of the arc AB, alright, this arc itself is given to be 10 cm. So given that this arc length is 10 cm, probably we'll need to find the angle since they give us the length, right? So question says find the angle AOB in radians. How do I find the angle AOB over here? I shall indicate this as my theta or angle AOB. Alright, so inside my arc length here, the information given to me is arc length. Length is involving 2 pi r. How do we find arc length? First one, let me write down the formula. Arc length is equals to theta over 360 times 2 pi r. But now, since we are going to find the answer in radian, it will be theta over, instead of 360, we'll replace this by 2 pi. Okay. Now let's put in all the numbers that we can get. Arc length is 10, so this is 10. And we cancel away the 2 pi with this 2 pi over here. And we are left with our radius. So the theta I need to find, the radius is given to be 12. So how do I find the answer? I just need to divide both sides by 12. Right, so theta, which is my angle, instead of writing theta, I'll write my angle AOB. This is, what is this? 10 divided by 12 or 12 divided by 10? I'm dividing both sides by 12, divide by 12. So it's 10 divided by 12. This gives me 5 over 6, or rather 0.83333 onwards. For working in 5SF, for angle for radian is always in decimals most of the time, unless you want to keep it exact, then it'll be 5 over 6. If not, you can leave it as this answer. And we round it off to 3 sig figs. Okay, RAD, that's the units. So for angle for radian, 3 SF. Okay, working 5 SF. Now I know this is my angle. Let me update my diagram with the information needed. 0.83333. Alright, find the length of OX. So what do we have? We have a triangle over here. Okay, this is 12. This is my angle, 0.83333. And I need to find O and X. So using Tuaka, so adjacent, this is my adjacent, this is my hypotenuse. Okay, there's the 90 degrees. So Tuaka and so using cosine. So cosine of the angle 0.83333 adjacent, which is my XO or OX, over the hypotenuse 12. Cross multiplying, we are able to get our answer 12 times 0.83333. No, sorry, 12 times cosine 0.83333. Right, remember that your calculator must be radian mode. Right, and I get the number 8.06897. 1, 2, 3, 4, 5. So I round this off to 90. Is that okay? Right, and then finally 8.07 CF 3SF. I shall label this on my diagram. 690. Okay. Alright, so make sure your calculator is in radian mode. If not, your answer will be very different. Next part of the question says, find the area of the shaded region. How do I find the area of the whole shaded region? What is this picture made up of for the shaded region? I need to take the whole sector over here, whole minus sector, minus away which other portion? I need to subtract away the area of this triangle over here. I can use area of triangle half AB sine C instead of half times base times height, right? So I know the angle and I know the length. So that means, technically speaking, area of the shaded figure, I need to find the whole big piece first. Let me draw this out. So this sector minus the area of the small triangle over here. Okay, I know this angle is 0.83333. This is 12 as the radius. And this is 8.0690. This is 12. This angle 0.8333. So using 1, 2, 3, 4, 5. Right? So using the following formulas, area of the shaded region will be taking the sector theta, which is 0.83333 over, instead of 360, we use 2 pi times pi r squared. You notice what can be cancelled away? The pi can be cancelled away. Minus the area of a triangle, we can use half AB sine C. Right? And simplifying, we should be able to get our answers. And the answer is, make sure what you're doing now is in radian mode, because it involves sine square minus 0.5 times 12 times 8.0690 times sine 0.83333. Alright. I got so many 3. 1, 2, 3, 4. Okay, correct. Right, then we can get my answer 24.165, rounding off to 3 sig fig, 24.2 cm squared, 3SF. Now, some of you might prefer to do it different, step by step, part by part. You can first find the area of the sector, then you find the area of triangle, then you subtract each other. No problem. Alright, the working is correct. The answer will still be the same. Alright, now let's move on to the next part of the question. Question says, find the perimeter of the shaded region. Let's analyze a little bit of this perimeter. What is in the perimeter? So I have the shaded region. I have the first, this arc length is already 10. Then what are the other sides that I will need? Oh, I'll need this portion over here. How do I find this portion? Well, the whole thing BO is 12 and this is 8.06. So this portion BX you just need to subtract, right? So BX is 12 minus 8.0690. So first part I have this one here is 10. This small portion over here BX 12 minus 8.0690. That gives me 3.931. And last but not least, I need to find this portion over here. How do I find this length AX? Well, this length AX is part of the triangle 12 and 8.0. And we have a right angle triangle, so we can easily use the Pythagoras theorem. Very good. So AX over here, this one AX will be square root of, now is this the short side of the hypotenuse? This is the shorter side, right? So we'll take the hypotenuse 12 square minus 8.0690 square. So with subtraction. Okay, and I get my answer 8.882. 1, 2, 3, 4, 5, 1. Then my final answer, the perimeter, will be to add up all the three different portions. 10 plus 3.931 plus 8.8821. And I get my answer 22.8131, rounding it off 22.8 cm. So 3 sm. Have you gotten your answer? Okay, now the very important thing to do, can all of you just do me a favor? Change your calculator back to the degree mode. Okay, because you may need to use it to solve questions involving bearings, trigonometry, and they are mostly in degree mode. So please make sure you change your calculator back to the degree mode. When you need to do tests and examples and questions or worksheet, work on questions with the Radian mode in the last, so that at least all your answers are not affected if you use the wrong mode on your calculator. Alright, I'll see you for the next lesson. Goodbye.